Hello friends, I welcome you in lecture number 5 on applications of integration. We are discussing disk method for finding the volume of solid of revolution. So if we recall, we have this formula for the volume of solid which is revolved about x-axis, integral of pi y square with respect to x with given limits of integration for variable x. So if we are rotating the plane region about x-axis, we are integrating with respect to x, and radius of the circular disc which is the cross section of the solid will be equal to y. Now suppose we are considering rotation about the y-axis, then in this formula we will replace x by y and y by x. So we have this type of formula pi x square dy with limits of y, which we will find out in the problem. So here we consider y as a function of x, so that this is ultimately going to be function of x. Similarly here x will be a function of y, and here we will consider the slice of solid perpendicular to y-axis, because we are going to consider rotation of the region about y-axis. We will consider the cross section of the solid which will be generated, and that cross section will be perpendicular to y-axis. So the cross section will be a circular disc in this shape. So radius of that circular disc will be equal to x and thickness will be delta y. So today we are going to discuss one problem in which we will find out the volume of solid which is generated by revolving the given region about the y-axis. So first we understand this question. Find the volume of the solid generated by revolving the region between the y-axis and the curve x equal to 2 square root of y, where y lies between 0 and 4 about the y-axis. So first we sketch the plane region which we have to rotate about y-axis. So for example, suppose we consider this two-dimensional plane, and suppose we denote this is x-axis. Here we have y-axis, given curve is x equal to 2 square root of y, and if we take square on both sides we have x square equal to 4y. So it is a parabola, and it opens in this direction, upward direction, and y lies between 0 and 4. So we have to consider the appropriate scale. Suppose this much scale is 1, so we have 2 here, this is approximately 3 and 4, so 0, and here we have 4, and we have to consider the region between the y-axis and the curve x equal to 2 square root of y, and y lies between 0 and 4. So suppose I consider x equal to 0 in this equation. If I consider y equal to 0 here, then I will obtain x equal to 0. So one point of intersection is 0, 0. If I take y equal to 4 here, then x will be equal to 2 into square root of 4, that is 2 into plus or minus 2, that is plus or minus 4. So if for y equal to 4 we have 4 comma plus or minus 4. So if we consider y equal to 4, value of x is also 4. So we consider this much scale as 1. So 1, 2, 3, 4, and we have somewhere here. So now we consider the part of parabola between y equal to 0 and 4, and we have to consider region between the y-axis and the curve. So this is the part of the parabola between y-axis and this is part of the parabola to the right side of y-axis, and we have to consider the region between the y-axis and this parabola. For example, this is y-axis and this is the parabola, so we have to consider the region between the y-axis and this parabola, and from y equal to 0 to 4, so we consider this portion, part of the region between y-axis and this parabola. Now we have to rotate this region about the y-axis. So first we try to imagine a solid which will be generated by rotating this plane region about y-axis. So for that we again sketch this here somewhere. So first we consider this much scale is, so here approximately we are rotating this region about y-axis. So first we copy this is on the right side of y-axis we have this shape, so we will have this same mirror image on the left hand side of y-axis. So we copy this. First we find out the copy or mirror image of this about y-axis. So we have this type of mirror image, and now it is easy, we join these two and we will obtain this type of solid which is generated by revolving this region about y-axis. So here we are rotating this plane region about y-axis, and the solid which will be generated will be in this form. Okay, this is three-dimensional solid, but we are just sketching it into two-dimensional plane to understand this method. Now we have to find out the volume of this solid which is generated by revolution of this plane region. So for that we will consider the cross section of this solid which is perpendicular to y-axis, and we can see if we take the cross section perpendicular to y-axis, it will be a circular disc which will look like this. Cross section perpendicular to y-axis will be a circular disc of some thickness or height that we consider as delta y, and center of this circular disc will be on y-axis, so its radius is this distance from point on the y-axis to the point on this parabola, that is this distance, that is denoted by x, will be the radius of this circular disc which is the cross section of this solid perpendicular to axis of rotation which is y-axis. Here axis of rotation is y-axis, therefore we are taking a cross section of this solid which is perpendicular to y-axis. That cross section is a circular disc of radius x and thickness delta y. So once we have this, we can have value of x in terms of y. It is already given that x is equal to 2 square root of y, and y lies between 0 and 4. So once we have this radius of circular disc, we have the formula for the volume of solid which is generated. Volume of solid is denoted by V, and it is equal to integral of this pi x square with respect to y, and the value of y is in between 0 and 4. Okay, that we can see here. At this point value of y is 0, at this point it is 4. So we have to consider this type of cross sections, and if we consider infinite number of cross sections, or if number of cross sections tends to infinity, and if we take volume for each cross section and if we take their sum, then their sum will be given by this definite integral of this pi x square times dy. Now we have value of x that we can substitute here. Y is from 0 to 4. Value of x is 2 square root of y. So here we have 2 times square root of y whole square integral with respect to y. This is going to be pi times integral from 0 to 4. Square of 2 is 4 square root of y square, that is y dy. Now this is very easy. Integral 4 times y square divided by 2. Limits of y are from 0 to 4 and we can cancel out 2 here. So we have 2y square. Value of y is from 0 to 4. If we take y equal to 4, we have 4 square minus 0 and this is nothing but 16. So the volume is 32 times pi. So this is the volume of solid which is obtained by rotating the region about the y-axis, or the axis of rotation is y-axis, and the formula for this is integral of pi x square dy from x equal to 0 to 4. X is the radius of the circular disc and it is given by x equal to 2 times square root of y. So this is very easy. Either we have to integrate with respect to x or y. That will be decided by the axis of rotation. If we are rotating about x-axis, we will integrate with respect to x, and radius of circular disc will be equal to y, and that will be a function of x. If we are considering rotation about y-axis, then volume will be given by integral with respect to variable y, and x will be the radius of circular disc, and that will be a function of y. So for disc method, we will remember these two formulas. If we have rotation about x-axis, the formula is pi y square dx with given limits of x, and if rotation is about y-axis, integral is equal to pi x square. Integral is with respect to y from given limits of y. So here rotation is about x-axis, so radius of circular disc will be y. Okay, this radius is going to be y, and that is going to be a function of x. Okay, sometimes we can denote this by, if we consider y as a radius of circular disc, then it is a function of x. So we can rewrite this as pi into radius function, which is a function of x dx, and here circular disc will be in this shape and its radius will be equal to x, and x is going to be function of y here. So this we can rewrite as integral from c to d pi times function of y whole square dy. So you don't have to cram all these things. You can just remember that how we are imagining or how we find out the rough sketch of this solid by taking the mirror images of given curves of plane region, and from the rough sketch of the solid, by taking cross section, we can decide that which formula will be applicable. So this is all about this session. I hope you like it. Thank you very much.